Okay, so we've looked at logarithms, what they mean, in addition to changing back and forth between logarithmic and exponential form. We talked a little bit about how this is kind of a similar relationship to how you learned about adding and subtracting, or multiplying and dividing, how they can undo each other. And today we're going to look at how we can use these logs, that relationship between exponents and logarithms, to solve for an x in a problem. And so we're going to go through several examples here together, probably about 6 examples. And I want you to see how we use this relationship of rewriting your equation in order to solve for an x. So you see our first problem here, we have 25 equals 10 to the x minus 1 power. And right now we don't have anything that we can kind of undo with those methods that we've learned in the past. And so what we need to do is, right now this is written as an exponent, we need to write it as a logarithm. And so what we're going to do is we're going to rewrite that. Now remember, you have some methods, either that A to B, you have the L and the E that I showed you. You may just have it written in your notes that you can go back and look at. But what we're going to do is we're going to go ahead and rewrite this. And when we rewrite this, it will be log base 10 of 25 equals x minus 1. And now you see we have that x nearly all by itself. That's always our goal as we're solving for x, is to get that x by itself. And what we need to do yet is we need to now add a 1 to both sides. So I'm going to rewrite this, and it's going to say 1 plus log base 10 of 25 equals x. And look at that. We've gotten that x all by itself by rewriting it and then being able to kind of undo some of the other things. Pay attention here that I wrote that 1 out in the front. We're not adding 1 into this logarithm. So you'd be really careful about how you write it. Sometimes if we put it in the back, we think it's still in that logarithm, and that's not where we're adding it. So make sure that you have it written in the right form. And at this point, what we could do is we could type this into a calculator if we wanted to know a decimal answer, or we could leave it as a logarithm. We'll look in our next lesson about how we might rewrite this to be more exact. But this is the basic idea of how we're going to use that relationship to rewrite it in order to solve for an x. So then once I have it like this, like I said, I can find that not exact answer, a decimal answer. Have a calculator. Make sure you're either using that TI-84 that's on your Chromebook. You're using one that you can hold on to. Maybe you're using the one on your phone. Any of those should have a logarithm button. And because this says log base 10, on your calculator, it will just look like log log. It won't say anything down there, so just know it's the same one. So when I type this in, 1 plus the log of 25, make sure 25 is in those parentheses, my answer is 2.3979. Pay careful attention to that rounding, right? If you need some practice on how to round, make sure you let me know. But this is how we can find that x value. Now you'll see the next one here, we have a natural log. This is the natural log of 2x plus 3 equals 4. You'll remember that this natural log and e have a special relationship, right? Really, when we write the natural log, it means log base e. And so what we can do is, to undo anything that you see as a natural log, we're going to rewrite it where we're raising both of them. That base e now is how we would rewrite it. Okay, so 2x plus 3 is equal to base e, right? There's a base e down here to the 4th power. And we want to get this x by itself. So we're going to subtract 3 from both sides. And the other methods of kind of undoing that we're familiar with, we still want to get that x by itself, so we can see that we need to divide this both sides by 2. And we're going to get x is equal to e to the 4th minus 3 divided by 2. Now, really important to remember, e is a number. It's not a variable. So use that button on your calculator that says e. We're not going to put in an approximation, but you can plug this whole thing right into your calculator. Be careful about how you plug it in, because this really should be in parentheses to kind of keep it separate. Okay, so we're going to plug that in. If you don't know where your E button is, make sure that you send me a chat so I can help you find it. But as we enter this in our calculator, we're going to find that x is equal to 25.7991. If you get a different answer than that, will you just send me a message right now in the chat and let me know what your answer was? Okay, let's keep going. Let's keep looking at some examples. Now remember, our first thing that we need to do is rewrite this as an exponent. As we rewrite this problem, it's going to be 3 to the 4th power is equal to 5x plus 1. Now our x is written not as an exponent anymore, but just as a normal variable. So now we can use those methods that we've used to solve for that x. Make sure you're working until this x is completely by itself. So here we need to keep going, dividing both sides by 5. We're going to get x is equal to 3 to the 4th minus 1 divided by 5. Now let's take a look at that. We could plug it into our calculator, right, and find the value. But I want to kind of break this apart and take a look closer at it. Let's see, 3 to the 4th power is 81 minus 1 over 5. So it means 80 divided by 5, or 16. If you plugged it into your calculator, right, get your calculator out, make sure your entire numerator is in parentheses. Make sure that if a number is not an exponent, it should not be written in that exponent spot. Yeah, and we get 16. So whether you do it kind of mental math or plug it into your calculator, it won't matter. But be careful that if this were an E or if you had decimals in it, make sure you're not rounding it until the end. I would even recommend, if you ever see an E or a decimal that's going to happen before your final answer, just plug that whole thing into the calculator. You'll have the most exact answer. Okay, let's look at another one. Again, we first start by rewriting. So this will be 3 squared equals to x plus 1. So 9 is equal to x plus 1, which means x is equal to 8. Okay, let's look at 2 more examples. Before we start these 2 examples, I want you to go ahead in the chat, tell me that you've seen those first 4 examples, and then give me kind of where you feel you are with understanding how we use these logs to solve for x. Anywhere from a 1 being, I don't really get it, up to a 5 thinking, I'm pretty confident, give me some to try, I think I could do it, right? So send me a message right now in the chat. Okay, let's take a look at these 2. We want to get this x to be a normal number so we can solve for it. The first thing I need to do, I can't really touch this until I get rid of my 6, right? So we need to make sure we're dividing both sides by 6 first. Now when we get here, we want to rewrite it. I do not want my x as an exponent, so I need to rewrite this as a logarithm. So I'm going to have a log base 10 of 8 is equal to 2x. I need to get that x all by itself. So as I divide both sides by 2, I'm going to get to this point. Now, this is when I can plug it into a calculator, right? So I want to put in the log. Remember, if it doesn't have that 10 on it, it's okay. That's a common logarithm. And that's the one that shows up in your calculator, is that base 10. So we want the log of 8 divided by 2. And you should get x is equal to 0.4515. Okay, let's take a look at this last one. What I want you to do is, I encourage you to pause the video and give this one a try first before we go through it. Okay, did you pause it and give it a try first? Let's start by rewriting. We need to write this as an exponent. So it'll be 5 squared is equal to 3x minus 8. Well, I can simplify this part, so I'm going to rewrite it as 25. And now this looks really similar to things that we've been working on since algebra, right? Where we're just solving for this x. And we should get x is equal to 11. Will you go ahead in the chat, just tell me that you're done, and tell me what you think is the trickiest part of using these logarithms to solve for an x.